Yeah. Good morning, my dear students. Now I will go to discuss the crystal structure. There is a very important the unit. I think probably you might have studying in the chemistry also. Same terminology are there. Some of the basic definitions and all that. The same thing is there even in the chemistry also. But students, remember, this is at the same time very tough to understand this crystal structure because it needs more of what the imagination is required and all that. In order to crack it or in order to understand the subject more properly, I'm using some still pictures, the animations I'm using, and those pictures, some of the pictures I have taken directly from the internet. I have taken this. Okay, welcome to the crystal structure now. First, what is meant by space lattice? Here, just in loose language, I can say that these are the chairs. Chair 1, chair 2, chair 3, 4, 5. You see, all these chairs are what? They are arranged periodically or in particular order. All the chairs are arranged. Before understanding this definition, just I'm giving you one example. Suppose there is any one function is there in the college function. You are organized. The many chairs are organized here. All chairs are what? Empty. That is, all chairs are empty. But in that chair, the person can occupy that. Here, look at this. This lattice point. This I will call it as a one lattice point. If I move on the right side, I will get the same lattice point I will get. If I move down, another lattice point. If I move here, another lattice point. If I move up, another lattice point. Let us come to here. That is. Again, one lattice point right side, one lattice point left side, one lattice point above, one lattice point down. Like this, you can study anywhere in this entire crystal structure. Here, the arrangement of atoms or environmental condition about any one lattice point, either on the right side or left side or up or down, the environmental condition is what it is same here. The repetition of same lattice points in x direction, y direction and z direction. That is called as in what? Space lattice. It is called as in what? Space lattice. Come to the exact definition. A space lattice is defined as an infinite array of imaginary points. This is important. Many people say not at this. It is an imaginary point arranged in a regular periodic fashion. Arranged in a regular periodic fashion in three-dimensional space, such that each point in the lattice point has exactly identical surroundings. See, just I told you this about this point, about this point. You see, now I'm considering this point. I'm considering about this point, about this point. Either you can move on the right side or you can move on the what left side. See, that is here you are getting what? Same identical lattice point you are getting up, down, right, left. Again about this point also, right, left, up, down. That is what? Everywhere there is you are getting what? Identical surround. This is called as what? Space lattice. Remember students, these are nothing but what? Imaginary points. A space lattice is defined as an array of, is an infinite array of imaginary points arranged in a what? Regular periodic fashion in three-dimensional space such that each point in the space lattice has exactly identical surroundings. And so written here, the imaginary points are also called as what? Lattice points. Okay. Here, each lattice point represents the location of atoms. That means there is an empty chair. In that chair, a person can occupy. No? In the same fashion, either atoms or ions can be placed in each chair, in each lattice point. Here, it is nothing but a person. It is nothing but a what? Chair. Here, how the person is occupying in this chair now, in the same fashion, the atoms or ions are occupied in each lattice point. Now you see, this lattice plus basis, it is all together, it's called a crystal structure. It is called as a what? Crystal structure. This is base lattice. These are the what? The bases. It may be single atom, or it may be the ions, sodium chloride, cesium chloride, but like that. It may be ion. Here, atom or ion is surrounded by the what? Each lattice point. Altogether, I will call it as a what? Crystal structure. What are the definition of bases here? The addition of atoms or ions or molecules to each lattice point in a crystal structure. A crystal structure is what formed here. These group of atoms or ions or molecules is called as a what? Basis. What is the basis here? The group of atoms or ions or molecules is nothing but what? Basis here. This is the basic definition of what is lattice and what is basis. Some people, they will call it as a lattice. They will call it as a what? Lattice. You can pronounce it as a lattice or lattice. You can both you can pronounce it. Okay. Next. Now try to understand what is the translational factor. That is translational factor. Okay. You know that in the vectors algebra, x is represented by a and y is represented by the what? Unit vector b, and z is represented by the what? K, unit vector a, b, c, like that. A, b, c. Okay. But of course, here I have taken only about the two-dimensional lattice space. I have taken only two-dimensional space here. Here, from here to here, one lattice point. Distance is what? A. Again, from here to here, it becomes 2a. Here, it becomes 3a. It becomes what? 4a. Yes or notice? This is 1a, 2a, this is 3a, this is what? 4a. Because this is the origin, that is. This is the origin I'm considering here. This point, I will call it as a what? Origin, that is. From the origin, I can move on the right side, or else what? Left side, I can move it here. That is 1a, 2a, 3a, 4a. Next, if I move it along y-axis, it is 1b. Next, 2b. This is 3b. This is what? 4b and all that. In general, now I want to represent this point, or I want to represent this point, or I want to represent this point. What is the location of this point? Is represented by the factor r equal to n1a plus n2b. n1a plus n2b. What is n1 and n2? n1 and n2 are the integers. n1 and n2 are the what? Integers. And a and b are the what? The primitive vectors or unit vectors along the along x direction and along what? Y direction. Students, yeah. In this example, that is, in this example, here, taking here, the position vector r bar equal to this. I want to represent this point. For this point, 1a, 2a, 3a, 4a. Can I write like this? 4a I am writing. Plus, along y direction, 1b, 2b, and this is what? 3b. This is the what? Nothing but what? Translational factor. The concept of the translational factor, what in the coordinate system, what it represents is, it is a position of the lattice point in the space here. The coordinate system is used to represent the position of the lattice point in space lattice is called as a what? Translational factor. Please understand, student, what is meant by translation vector? It is in the coordinate system. Any point in the lattice space is represented by the coordinates. That is called as what? Translational factor. That is the point. Some books they will call it as x, y, and z. They will call it as no problem. But I am calling it as a B. If it is a 3-dimensional is there, then I will call it as a what? C. That is next. Now come to the unit cell, that is. Before understanding this unit cell here, imagine yourself now you are constructing the wall, that is compound wall. How you are constructing the compound wall? By using the bricks. You are placing the bricks either on the right side, left side, up, down, in all that. The repetition of the same bricks The repetition of the same bricks on the right side, above, left side, down, you are constructing the entire wall you are constructing. Here, the basic component in the wall is what? Brick. That is the smallest unit. One brick is the smallest unit. That's why now I will define unit cell is defined as the smallest portion of the crystal lattice. What is unit cell? It is defined as the what? Smallest portion of the crystal lattice. And the repetition of which in 3 dimensions produces the what? Crystal structure. I give an example. The bricks is there. Go on, place the bricks above, down, left, right, and all. You are building your what you are constructed the what? One compound wall you constructed or wall you constructed. In the same fashion, the repetition of the smallest portion of the cell. That is the smallest portion of the cell. By repeating that, what you are getting is one entire crystal structure you are getting here. Okay, you see, students, this is one unit cell. It is unit cell. That is that here I'll write like this. This is the one unit cell, or else I can represent like this. It is a one unit cell. Now I'll place another unit cell. I will place another unit cell. By repetition of all these things, either on the right side or in the what downside, then you are constructed the what entire the crystal space, crystal structure. I can what construct here. That is okay. Next one is here that what are the types of unit cell here? In the unit cell, there are 2 types of unit cells are there. One is a primitive cell here. One is what? Primitive cell here, students. This is highlighter. This is the what? Primitive cell. Primitive cell, that is unit cell is divided into what are 2 types. One is, so 1 minute, here. That unit cell is, just 1 minute. So this unit cell is divided into what? 2 types. One is primitive and another one is what? Non-primitive cell. That is, one is unit cell and another one is what? Non-primitive cell. In the primitive cell, what happens is, if the unit cell, it has only one lattice point and atoms only at the corners is called as what? Primitive cell, students. Only atoms are where they are present here. The atoms are present only at the where? Corners. Remember, students. What is that? If unit cell has only one lattice point and atoms are present only at the corners, is called as what? Primitive cell. What is one unit cell? I will tell you in another 2 minutes. Remember, it has what? Atoms are what? Only at the where? Only at the corners here. That is only at the corners. Such cell I will call it as what? Primitive cell and all that. Next one is non-primitive cell. In the non-primitive cell, if cell contains more than one lattice point, here. In the previous case, it has got only one lattice point, but here it contains more than one lattice point. Then it is called as a what? Non-primitive cell here. Look into this diagram, students. Now, okay, this is unit cell, primitive cell, you see, because it contains only the atoms are what? Where? At the corners, at this point, and what? At this point. And next, even that is next one is B. I will consider this B also. You see. In the B also like this. One lattice point here, one lattice point here, one lattice point here, one lattice point here, one lattice point here. It contains atoms are only at the where? Corners here. And look into it. Another one there is another one here. C. C is also same thing, you see. It is like this. One lattice point here, one lattice point here, one lattice point here, one lattice point here. So that here A, B and C, that is A, B and C, that is here in this diagram, A, B and C are called as a what? They are called as a what? Primitive cell. What is the definition of primitive cell? It has got only one lattice point. That I will explain what is one lattice point. Please understand, it has only the atoms at the corner is called as a what? Primitive cell. But in the non-primitive cell, not only in the corner, even at the face, that is what front face, left face, upper face, there is also one lattice bond is there. Those are called as what non-primitive cell. For example, you say now. For example, now here you see E is there no in this E diagram. One lattice bond is there at the center. One lattice bond is there at the center. But of course, atoms are there at the corners. 1, 2, 3, 4. Apart from that, it has got one lattice bond at the center. Come to the point, this one D. You see, here one lattice bond, second, third, fourth, and apart from that, that is what here also it is. It is not corner. It is not a corner. And here also, this is D, E, F. You see this structure. You see. 1, 2, 3, 4. Apart from that, that is one atom is here and another atom is what here. And these are called as what non-primitive cell here. Totally, I would say that. Okay, next one. Now, here I use the word primitive cell means if unit cell which has only one lattice point. What is the meaning of it? I will explain it now. Okay, I will explain it with a two-dimensional diagram. These are the squares I am taking here. One squares, 1, 2, 3, 4, like that. Squares I am taking. Here you see one lattice point is situated at the corner. That is one lattice point is there at the corner. That is one lattice point at the corner. This point. This lattice point is there now. It is shared between four neighboring that is tiles. Imagine these are the tiles you can imagine. This lattice point shared between 1, 2, 3, 4. I think I would hope that is clear for you. That is here, whatever the atom is there at the corner, this atom, the atom which is present at the corner, no, this is the one corner. This corner atom, it is shared between this one, this one, this one, this one. What is the contribution here? 1/4. 1/4. That is one fruit is there. That fruit is shared between what? 4 members. That is 1/4 contribution made to this cell. Similarly, that is what? Similarly, this corner, you see, this is also shared between four neighboring one. 1, 2, 3, 4 neighboring cells here. What is the contribution here? This also 1/4. Similarly, for this also 1/4 because 1, 2, 3, 4. Again 1, 2, 3, 4. Like that 1/4 into 4. 1/4 into 4 equal to what? 1. That means in any primitive cell, the number of lattice points is equal to 1 only. That is, I think it's clear. That is definition. What is that? If unit cell which has only one lattice point, then it is called as a what? Primitive cell. That is, if unit cell has got only one lattice point, then it is called as a what? That is called as a what? Primitive cell. That is. But in some of the cases I shown you, that is in the E, D, F, where there is more than one lattice point is there. That is a more than one lattice point is there. Now, 1 minute, I will share you. I'll show you some structures. Okay. Okay. Now, here, now, 1 minute, 1 minute.
A, from this point to this point, it looks like this, which is 1/8 of the sphere. The 8 atoms are the atom. This portion of the atom is 1/8 of the entire atom. This portion of the atom also contributes 1/8 part of the entire atom, and so on. There are 8 portions of the atom at the corner. Therefore, the number of atoms in the simple cubic cell is 8 corner atoms multiplied by 1/8 atoms per unit cell, which is 1. From this point to this point, it is the lat, which is half of the sphere. When you cut a sphere into half, it looks like this, which is half of the sphere. When you further cut this part into 2 equal parts, it looks like this, which is 1/4 part of the sphere. When you further cut this part into 2 equal parts, it looks like this, which is 1/8 of the sphere. The 8 atoms are the corners are cut into 1/8 part of the atom. This portion of the atom is 1/8 of the entire atom. This portion of the atom also contributes 1/8 part of the entire atom, and so on. There are 8 portions of the atom at the corner. Therefore, the number of atoms in the simple cubic cell is 8.
Okay. Now you understood this, but here I give the example for the two-dimensional space where what elevation I've shown you, it is where it is three-dimensional space. There they have taken it is what 1/8. They have taken it as what 1/8 in 3 dimension in the cubic structure. Into cube has got how many corners are there? 8 corners, so that it is how many atoms are there? Only one atom is there for unit cell in the simple cubic structure. Next. Now, this is the simple cubic structure. That is simple cubic structure. It has got one corner, second, third corner, fourth corner, fifth corner, sixth corner, seventh corner, eighth corner. At each corner, the each lattice point contribution is, just now I showed the elevation, it is only what 1/8. It is only 1/8. Now, like that, how many corners are there? One corner, second corner, third corner, fourth, fifth, sixth, seventh, eighth. Into what? A equal to one atom. That is, it is a three-dimensional diagram.